In this example, we want to prove that a square matrix with two identical rows or columns has determinant 0. So we'll tackle the example in terms of rows, but the analogous argument will work for columns. So we'll let A be the given matrix. Okay, and let's say that row I is equal to row J. Then we could go ahead and do a change of some elementary row operations and replace row J with row J minus row I. Now this creates the matrix. We'll call it A star. A11, A12, A1n. So somewhere in here there's a row of zeros because row I minus row J the entries in row J are equal to the entries in row I, so row I minus row J gives me a row of zeros. So AM1, AM2, AMN. Now the determinant of A has to be equal to the determinant of A star, because elementary row operations of the form add a multiple of one row to another does not change the determinant. This is true since replacing a row with a multiple of another row plus the original row leaves determinants unchanged. But we know that any matrix that has a row or a column of zeros has determinant 0. So determinant of A star equals 0 by the Laplace equation. So therefore, determinant of A must also be 0. And so anytime you've got two identical rows or columns, anytime A is a square matrix that doesn't have full rank, you're going to have a determinant of 0.